So yes, tale of a data modeling blunder, or how I optimize the wrong thing and learn to drive properly. If it's not already clear, I'm into cars, so there's a bit of a car theme through the presentation. So first of all, a little bit about me. I work Power BI and Fabric. I've spent the last 5 years as the BI manager for Marsden. So if you don't know about Marsden's, we're a pub company. It's about 1,300 pubs up and down the UK. There's two local ones. So we've got Pitcher and Piano down by the canal, and then there's also Lost and Found at the top of Bennet's Hill. Yeah, bit about me: Power BI, Fabric, DAX, SQL, now AI. So I've had a slight change of role, but yeah, that's been my bread and butter for 5 years. Also like cars, as I say. That's why this deck is a bit car themed. And what we're going to walk through tonight is a real mistake that I made going back 18 months, something like that. That felt like a really good idea at the time, and then soon after realised it was not a good idea. As I say in that text, kind of set fire to production a little bit, but we managed to put the fire out soon after. And yeah, I'm only going to tell it after we fix the problem. So what am I going to go through? I'll set the scene. So like any good AI prompt, we'll go give everyone a bit of context. Then I'll go through the mistake. So a request came in, tried to solve it in a specific way, given the constraints we had at the time. Then I'll go through how we discovered the mistake and what sort of problems that was giving us. Then how we found a better long-term solution, some key takeaways, and then give you a chance to grill me a bit. So, setting the scene. Before I go through this slide anymore, does anybody have the luxury of having the Fabric capacity that they work with? Excellent, a good amount of people. Is anybody aware of the semantic model size limit that exists on each capacity? Okay, a few. So an important point to note, every Fabric SKU has got a ceiling on how much data you can have in a semantic model. I really hope there's not many people that experience hitting that limit. But for an F128, you're allowed a 50 gig model. However, there's a bit of a caveat, and that is that Microsoft recommends you only fill it about halfway. That leaves a lot of headroom for queries caching, to do refreshes and that sort of thing. If you fill it right to the top, things aren't going to run very well. So that's a bit of context. We had an F128 SKU at a point in time, and recently managed to actually scale down a little bit due to some optimizations. And this was our situation. So we had a 50 gig limit. We should really only have been using 25. We were already at 35. So things weren't looking too great. And we're a bit conscious of this issue and trying not to grow the model too much more. And then a request rolled in. So, as I mentioned, I work for Marsden, who are a pub company. One of the big cost lines for us as a business is labour. So how many staff are working at any given point in time? We already had some reporting available for labour. And what that allowed us to do is look by employee, by day, and see how many hours they've worked, which is great for kind of top line control to work out whether we're, our staffing levels are roughly in the right place and that sort of thing. However, when someone says, do we have the right number of staff on at 6 o'clock on a Friday, pretty useless. So the challenge was, how can we give the business the ability to look at labour at 15-minute granularity? And that gives us kind of two really big wins as far as reporting is concerned. So the first thing is we can see how busy we were at a certain point in time, and then line up whether we had the right number of staff on. So we could have a situation where people are twiddling their thumbs at lunchtime because there's 5 staff on and hardly any customers. But then in the evening, they've not got enough staff to cope. And if we repurpose those staff to a right place, we should be able to save a bit of money at lunchtime and then give people a better experience come the evening, and also hopefully sell a bit more, because someone might be able to go around and ask if someone wants another drink and that sort of thing. So really tangible business impact for getting this right. The challenge though was obviously 15-minute granularity is going to be a lot more data. So how do we try and solve it to start with? So I've come on to the original mistake. So what I came up with is, what I was trying to do is minimize how many rows we put into the model with the intention of not making it too much bigger. So I scratched my head and I thought, well, the best way we can store this data is every block of time we can store as a row. So each row would carry a start, an end, and a duration, and it would obviously have the context of the employee, the pub they've worked at, etc. So what that looked like in practice is a bit like this. So we imagine we have an employee that clocks in at 13 minutes past 11 in the morning, clocks out at 12:47 for a break, has 25 minutes off, clocks back in at 12 minutes past 1, and then works through till 3:38 in the afternoon. We could store it like those 3 rows at the bottom. So previously, this would have been just 1 row of data where you'd have an employee and a duration, which should be the sum of the 94 and 146, so 240 minutes. That's all we had previously. Now we're adding in more detail, but we've only got 3 rows as opposed to 1, but we should be able to slice it better. However, there's a problem with this. Before I go on to the next slide, can anyone clock, excuse the pun, what the problem is with this? Oh, okay. So typically in Power BI, obviously you have a relationship to be able to slice and dice. With this method, there's no way you can create a relationship, because you create a relationship, for example, on your start time, you don't really know, the model doesn't understand the duration. So yeah, basically, how do you draw those 3 rows on a chart that might have 15-minute increments? It's a tricky problem to solve. So again, I scratched my head and I thought about how best we do it. And obviously got to write DAX. So I had 3 goes. The first one was basically brute force. I was trying to prove, can I actually solve this problem? It wasn't pretty. I don't have a copy of the DAX. I wouldn't want to show it anyway, but I made it work. The problem though was that it was really slow. So running a query would deliver the right result, but it might take 20 seconds or something to run over all the data we had, which is definitely not something we could put in front of end users. So then I took a step back, optimized it a little bit, managed to improve the performance a touch. But in doing that, I managed to actually really frame the problem that I was trying to solve. So finally, channeled my inner Italian. Hopefully everyone knows Secret BI. I managed to come up with some DAX that was pretty performant at the time. So the first thing to note is if a query comes in and there's no filter being applied by hour of the day, so we're just looking at day level, actually we don't need to do anything clever. So one thing to note about the data is there's always a split at 6 o'clock in the morning. So as pubs go, our trading day runs 6 a.m. through to the following day, 6 a.m. So that if you're in the pub past midnight, that trade doesn't belong to another day. It's kind of the same trading day. The data always has that split in it. So if someone works from 4 a.m. until 8 a.m., which just happens, we have hotels, the source system splits it. So you end up with 2 rows. So you've got this nice clean cut for day. So if the query isn't filtering our table, we can completely ignore it all, just use the relationship we've got in the model from day, and it's going to give us the right answer. However, fun then starts when you do have some time constraints. So I realized essentially there were 4 scenarios. So if we imagine here we've got a time window, so a query comes in and someone's trying to analyze lunchtime. They're looking at, say, 11 o'clock in the morning until 2:30 in the afternoon. That here effectively represents our window. So that's the orange yellow bar. And then the red bar represents the shift that somebody has worked. So it's the block of time that we're looking at. So we've either got the time block sits inside the window. So if we're looking at 11 till 2:30, someone started at 12, ended at 2, their entire shift is inside the window. We've got the inverse of that, where someone works from 10 till 4, and the window sits inside their shift. And then you've, of course, got their shift starts inside the window or ends inside the window. So I managed to solve each one of those problems independently, and then glued it all together in one piece of DAX, which looked a bit like this. This is simplified. I do actually have the real DAX open, which here we go. Here's what it looked like. So here's my time window. Here's me checking whether the timetable is filtered. And then each one of these is an independent sum X, solves each one of those problems that gets added up. It worked really nicely. I tuned it. Tuned it. That was the tuning process. But I looked in DAX Studio, looked at the server timings, wasn't too heavy. I could run a query and it would complete in like 150 milliseconds, all happy. Gave it a test. We were looking okay. I thought, great, we've solved the problem. I've written the DAX to solve this weird row scenario. We've not taken up too much space in the model. And then we've gone through and actually built the reports off the back of this. So users could now actually, in the report, slice and dice by day part effectively. We could plot on a graph how many staff are on at any one given point in time. So what that led to was a bit of a discovery of a problem. So the reports got built. They went to trial. And has anybody used the fabric capacity metrics? A few. I know, John, you've done a talk on it before. It's not very good, but it does give you an idea as to how much your capacity has been used. And there's a graph basically with a dotted line and then some lines underneath it that tells you how much your capacity is being utilised. And during the trial phase, we saw it creep up a little bit. Wasn't too concerned. We went for full rollout and it got absolutely smashed. There's another concept that's worth noting, which is where we really start to feel pain. Within a fabric capacity, you can incur what's called an overage. So if you go above 100% utilization, it's kind of a soft ceiling. It will let you use more capacity than what you've got. The flip side, though, is a few minutes later, Microsoft come in, they throttle you, and they have that capacity back. And then what the end user sees to start with, they get a 20-second delay on their query, so things slow right down. And if you're really getting throttled, they get rejected, and you have big grey X's on your Power BI report. And that's what the position we got to. So at points we were scaling our capacity all the way up to F256 just to keep going. And if you don't know, an F128 is about 15 grand a month, 256 is 30 grand a month. You only pay for the point in time you're scaled up, but a costly mistake. So we clearly needed to go back to the drawing board, back into the pit. So we kind of said, okay, how else can we do this? And obviously, originally, what we were trying to do is minimize the number of rows we were putting into the model to make sure that we weren't going to take that 35 gig too much higher. We thought, well, if we don't do that, what's our other options? So originally we had our 3 rows, a shift, a break, and another shift. The alternative was, before we put the data into the model, write a bit of SQL, split that data out into 15-minute chunks. What that means, though, is we go from 3 rows to 21 rows because each block of time for each shift type needs its own row. So lots more rows. However, flip side is DAX is now just a sum. All we need to do is sum that hours column because we can create a relationship from our fact table that's now got a time in it over to our timetable, and the model's handling everything. So we gave it a try, rolled it out, and we saw a 30% drop in the entire capacity usage from making one change to one measure that affected one report. So it was pretty significant. Of course, the trade-off is we've put in more rows, so the model got bigger. What I realized was there's a much better way of optimizing for storage than purely looking at row count. And there was 2 really, really big takeaways. And I do have a real world example of this in a second. The way we've got things set up is we've pretty much only got one semantic model that does almost everything. So one source of the truth, all in one place. So we're trying to optimize this entire model. So we went to looking at all the different tables and everything that we had in this model. And there's a few things that jumped out. There were measures that behind the scenes were storing a really high level of precision. So they might have had 6 decimal places. We realized if we just rounded it down to 2 before we put the data in the model, we got a huge saving on storage. And I'll come on to an example of that in a sec. The other thing, has anyone heard of defragmenting tables in a semantic model? Just one, okay. Hopefully that means no one's needed to bother with this, but it's a really useful thing to know. So when a semantic model stores data, it won't actually store the data over and over again. For example, if I have an employee number and I'm storing that employee number as an important column, it won't store that employee number over and over again. It creates what's called a dictionary. So it will take that employee number, it will go to the dictionary, it will say, have I seen this before? If it hasn't, it will add in a new item and give it a surrogate key that will start at 1 and go up and up and up. And that surrogate key is what's actually been stored over and over again. So it's a far more optimal way of storing things. The caveat to that is your dictionaries, if you delete data, they never get rebuilt. So if we've got an employee that worked for us 6 months ago and we've now trimmed the data down and they're not in our data anymore, their record's still going to exist in that dictionary because it doesn't get rebuilt. And that's exactly what defrag does. It will go to those dictionaries, it will rebuild them, and any items in there that no longer are required, it will get rid of. And if you've got a scenario where maybe you're keeping a rolling 12 months of data in a model, that can have a really material impact after a while. So we learned these 2 things, and we managed to go back and optimize the storage in the model by using these methods. And then we didn't really have to care about the row count in our labor reporting. Here's an example. So this is 2 screenshots of a stock table that we've got in our data. Hopefully it's big enough to see. On the left-hand side is pre, and I'm going to draw your attention to this first column here, which we can't quite see, is total retail variance value. So give a stock take is how much gain or loss you've got in pounds. And to start with, that column total size is 214 megabytes, and it's got a 3.7 million unique values and a dictionary size of 165 megabytes. So that dictionary is by far the big part of the puzzle. So we did 2 things. That column was at 6 decimal places. It's pounds. We only care for 2 decimal places. So we rounded it down, reloaded all the data, and then we did the defrag. So we'll see on the right-hand side, the total retail variance value is now much further down the list because it's much smaller. And that column's become 24 megabytes. So getting on for a 90% reduction. We did remove a few rows. So the table went from nearly 11 million rows to just under 8 million rows. There's a bit of a difference there. But the really big bit is the fact that this column's now only got 200,000 unique values rather than 3.7 million. So that dictionary's got a lot smaller, and we've got rid of all the historical items in the dictionary that may no longer be applicable. That's a far better way of optimizing your storage in your model than row count. I've come to learn. And that's kind of the moral of the story, really. Optimize your semantic model for compute, not for row count. And to quote, I think SQL BI have probably said this in the past, the best DAX is no DAX. If we can get away with sums rather than doing anything clever, that is definitely the way to go. Let the model do the work, design it properly, and that's the way to go. I'll probably rattle through that way faster than I should have done, but I guess we were behind time, so we're okay. Q&A.
What's the reason for having like the big semantic model rather because it has smaller, lightweight, more manageable units?
The main reason for doing it is so that when we come and build a Power BI report, if we want to mash up 2 different bits of data, it's there. We don't have to segregate reports or that sort of thing. And it's quite normal that we might put sales alongside stock, sales alongside labour in particular, and that sort of thing. You've always got all the data you need in one place. The other thing we use Power BI semantic models for is the business. Our finance team in particular, our data analysts in our marketing team, they all use the same semantic model to get their data. So they will connect to it through Power Query and Excel, and they're singing from the same hymn sheet as all of our Power BI reports are. So one source of the truth, one place to maintain it all. That's the idea. But yeah, it does burn us sometimes.
Firstly, thanks for coming. I really enjoyed that, and it was really brave of you to talk about a mistake, because everybody comes here and presents their stuff, their best, don't they? Do you know what I mean? All the stuff that's brilliant, the agentic stuff that's great. Obviously, we're like Power BI bros, and Power BI is going to be like the centerpiece of everything that we talk about, and rightly so, because I think it's still the jewel in the crown of Microsoft. But the first thing we do when we write Power BI reports is get data, and it's that model for me that is so important. And I think the model is everything. And a bit about DAX, if you've got overly complicated DAX, it tends to suggest that's something not quite planned out to the model. Certainly where I work, we're making massive efforts to get the model right. And when we've got the model right, the DAX is much more straightforward and everything flows after that. So I think that modelling is really important. And we've certainly agonised over hours and hours and hours getting that absolutely bang on, because obviously you've made a mistake and got it right, but if you get it wrong, you might do cascading dependencies on that that you can't unwind. So I'm really enjoyed having to talk about modelling. So yeah, thanks.
Yeah, it's an important part of it, definitely. Jake?
So your model's getting quite large for your capacity size. Are you doing anything interesting with your refresh strategy?
Yes, so I mean, from day one, to be honest, we've partitioned the data, and then we've used the TMSL through PowerShell to refresh and create partitions on a daily basis. So to put that into context, behind the scenes in a model, you can partition your tables, and each partition will have its own query. So if you've got a SQL data source, you can put a piece of SQL in each partition, which means for us, like, sales is our biggest data source. There's 11 million rows a week coming in sales. Having them in independent partitions mean we don't have to refresh all of sales every day, which it would just be a nightmare. So some point in the week, I can't remember the job runs, we have a job that goes and creates a partition for the following week that has the SQL ready to go for next week's data. And then every morning, all we do is refresh the current week and the previous week, just in case any late data comes in. And we do that. Yes. So we also, for sales, it's a really good example because it's such a vast data source. For data that's older than a year, we basically point it at a view that compresses it. So it rips out some detail, shrinks the rows. So we go from having 11, 12 million rows in a weekly partition to about 5. And then for anything that's older than 2 years, we take even more out, and we can fit an entire year into a 40 million row partition. So the older it gets, the more granularity we take out, and it keeps the row size. I think it's like 800 million rows in total or something.
Does that mean your measures are checking to see the scope of any particular visuals, or you have some?
No, we just tell people, if you look at old data, expect less detail, which most people don't care for that much detail when they're looking that far back. I mean, to give an example, the most detail literally holds transaction. So we can go and look at basket level. And then we get rid of basket to start with, and we go to hour of the day rather than timestamp. And then we go just to day and then product category. So the older you go, the less detail, and tends not to catch people out too much.
This is some direct query. So now you were looking at that wrong thing.
No, this is import mode. Yeah. Yeah. Any other questions?
Question on the DAX you were showing, so I just jumped ahead of everyone. Based on the DAX you have there, it is in tabular editor.
Yes.
I reckon you didn't build that in tabular editor. That would be insane. So
Oh yeah.
what did you?
DAX Studio.
Right.
So
maybe you just
the four,
visualize it.
yeah. So the 4 scenarios I solved independently in DAX Studio,
Yeah.
made sure they worked, and then brought it all together in tabular editor. Yeah.
Perfect. So are there more questions there?
Ruben?
Ruben? Yeah, it was just that initial where you notice the capacity is going above that, what tools do you use for tracking that capacity?
So that is the capacity metrics app, which I can probably show you. I've got it open almost all the time because we're always keeping an eye on it. But yes, this is the Fabric Capacity Metrics app. You can go and grab it. So if you're on Power BI and you go get apps, it's a template app that you can go and get effectively from Microsoft. And then you chuck it on your tenant, connect it all up. And then you end up with this, which you know, expand the time frame on. You can see it's been a bit of a hectic few weeks, but yeah, that dotted line is it's the ceiling. It's like a soft ceiling. That's where you can borrow a bit of capacity. So wherever these lines go over the dotted line, that's where you'll get throttled.
Right.
There is a new feature we've got turned on, which means you just pay more money rather than getting throttled. If the spikes go too high, then you could end up with a big bill. So we're carefully monitoring it.
You've got bursts and smoothing, so you'll guess you was at over capacity over 24 hours. Because normally plays back, I mean, estimates is about every 30 seconds to try to replay back your data. If you can't smooth it out,
Yeah.
that's when you start getting throttled, isn't it?
Yes.
After a while.
Yeah. And you can see it on the
Yeah.
And it's an hour for active projection, 24 hours for background projection.
Yeah.
That's the second way for us to replay back the data into the take it down because it stops your interactive workloads from failing. That's really quite funky. You have to ramp it up twice, quite amazing.
Oh no, yeah, not a good place to be. But you can see it on this chart here. This is the overages now because we've got the billing turned on. We're not actually getting throttled here. But I'll make this a bit bigger. The orange line effectively represents how much capacity you've borrowed from Microsoft. So if it goes up, you're borrowing. When it comes down, you're being throttled and not having it back. You're not necessarily always being throttled. If things are inactive, then I'll have it back and there'll be no impact to the end users. So yeah,
Okay.
that's where you go.
Yeah,
Really
thanks
useful
for that.
tool. If you start to feel things are a bit slow, you can come in and have a look at what's going on.
Thanks.
Anything else?
But a heavy spike interactive.
Yes. Yeah.
It's a lot bigger than capacities I've seen.
Yeah.
I guess
Yes.
it's a UK company as well. Like everyone's looking at exactly the same time.
Yeah, there is that.
It's the first report they all open at 9 in the morning and it just goes.
There's a bit of that, and more so, like all of our pubs have access to this, so we could have in the morning if everyone goes and checks. So it could be like it won't actually be this, but it could in theory be like 1,300 users all looking at once. It's probably more like you know, like 200 or 300 at a time in the morning.
Do you have query scale out?
I can't remember. Definitely looked at it in the past. Yeah, I can't remember. Anything else?
Do you have like an acceptable lifetime for a visual to kind of, if it takes 3 seconds, that's okay.
Yeah, I don't know if we've actually kind of agreed an acceptable time, but I feel like if a Power BI page takes more than like 10 seconds to run, then we'd be going, okay, what can we optimize? That being said, if the capacity's slammed, then it might take a bit longer. So you kind of have to balance it with whether the capacity's big or busy or not.
And then with those spikes, I mean, what's the feedback from the business?
Make it faster.
Yeah, but is there like, do you kind of see almost like engagement kind of dropping, and like people are like, oh, this is just too long? I mean,
So I think people are kind of used to the fact that at busy times things can get a bit slow. Like we've been quite good at communicating that out to people. But since we put that optimization in with the labour and since we had the overage billing on, it's all gone quiet. And we have now actually managed to, so our model now, those optimizations I spoke about, we're now at 16 gig. So we pretty much half from where we were at 35 with more data in there from going through and optimizing all that sort of stuff. So it's had a huge impact. And that's now meant we've been able to scale down to F64. So we've saved a bit of money on having to have an F128 all the time. So, and that's kind of paid for the overage billing. So we've got smaller, probably spending a little bit less, but performance is better. So yeah, not a bad compromise.
How long did it take you to solve the problem?
I think once I'd realised the right way to be solving it, it was probably a couple of weeks. I've just, right, let's just bash this out, do a test, make sure it works. The hardest bit was probably cutting over, because obviously everyone's always looking at this sort of stuff. So yeah, just having a cut over plan with some backouts and stuff like that, was probably sort of the most planning and orchestrating.
It's not bad luck, John.
Yeah.
This community can help you as well, because I've seen quite a few presentations on specifically optimizing for compute the way you've done it as well. So
Definitely, yeah. I think, I've heard the message before, get your model right. I suppose at this point in time, I thought I was being really clever by not putting too many rows in, but quickly realised that I was being a fool.
It's definitely a secret behind that.
Yes, yeah, absolutely.
Question, Damien?
Yeah, have you got any discount vouchers for the picture and piano, please?
Joking apart, I can get 30% off. I know we normally go to Turtle Bay, but we could always go to
Maybe you
PMP.
changed the name then.
It seems to me you've got a traditional lambda sort of hot and cold, like today's important and hot from 6 a.m, but yesterday isn't. Have you thought about dividing the problem up a bit? Because, I mean, maybe it sounds like two models that John's touching on, but you wouldn't have like 30 billion rows in a today data set. I mean, that's hot for the business.
Yeah, I mean, I suppose that's what we've tried to handle with the partitioning, in the sense that older the data gets, the more we aggregate away detail. So we tried to handle it like that, and we're in a position now where we're kind of happy with where the model is. We've actually managed to save a bit of money, and no one's complained about not having enough data. So I think we tried to get there, and I think we're in a fairly good position. But if we were pushed further, then yeah, spinning up another model to cater to different things is definitely something we'd have to consider.